Manik Talwani is currently a professor emeritus at Rice University. Professor Manik Talwani needs no introduction among the geophysics community. Dr. Talwani is one of the pioneers of modern applied geophysics, and he is an internationally recognized geophysicist who has carried out research in seismology as well as gravity and magnetics. Dr. Talwani got his bachelor's and master's from Delhi University and his PhD in geophysics in 1959 from Columbia University. During his long career spanning almost 60 years, Dr. Talwani served as the director of Lamont Doherty Geological Observatory from 1974 until 1981. After he left Lamont to join Gulf Oil as the first as a director of the Center for Marine Crustal Studies and later as a chief scientist. In 1985, Dr. Talwani was appointed as a Schlumberger Chair in Advanced Studies and Research, and he served simultaneously as the director of Geotechnology Research Institute of Houston. Advanced Research Center, Houston Advanced Research Center. Dr. Talwani also served as the president and CEO of the Integrated Ocean Drilling Program Management International in Washington, D.C. from 2004 to 2009. Dr. Talwani has served on numerous national and international committees and has authored or co-authored more than 150 peer-reviewed articles and 7 books. Dr. Talwani has received an amazing list of awards, including James B. McElwain Award and the Maurice Ewing Medal from the American Geophysical Union, the Alfred Wegener Medal from the European Union of Geoscience, the Emil Weichert Award from the German Geophysical Society, the George P. Woolard Award from Geological Society of America, and the Krishnan Medal from the Indian Geophysical Union. And the list goes on, but now I will let Dr. Talwani speak and guide you guys in this event.
Can you hear me all right?
Yes, yes.
You can. I'm not muted anymore, am I?
No, yeah, we can hear you.
Okay. Firstly, let me thank Dr. Mishra for the invitation to talk and to this very talented group of young men and women. Let me also thank him for the excellent introduction that he gave. I'm very flattered. I also must say that I totally agree with what Dr. Baker said today. Perseverance is indeed very important. And I think she gave an excellent introduction to what foreign students need to know before they start thinking about coming to the United States. Now, somebody mentioned the word success, and I would say the keys to success are no mystery, and you know what they are. I'm sure you're being told all the time, work hard, do your homework, listen to your parents, etc., etc. No, I'm not going to give you a lecture on how you can become rich and famous and millionaire software engineers. I'm not even going to tell you to necessarily follow me in my profession, although after hearing what I have to talk about, you may want to do that. I'm going to do something else. In life, one comes across difficulties and challenges. I'm not going to talk about various challenges. I am going to talk about various challenges that I met in my life. Now, the challenges that I faced are going to be very different from the challenges that you're going to face. But at least by reciting my challenges, it might give you an example of how you may have to face yours to accomplish your goals. Also keep in mind that overcoming challenges and with perseverance, as Dr. Baker suggested, has its rewards. So let me start with one hot summer day in New Delhi. I had finished my Master of Science degree in physics, and I wanted to continue studying, not in physics, but in geophysics. Geophysics, or earth science is another word, deals with the application of physics to solving the geological mysteries within the earth. However, at that time, there was no university in India where I could study geophysics. Suddenly, out of the blue, I received a message from the Ministry of Education in India that a scholarship was available to study in Norway. But isn't it very cold in Norway? Who wants to go there? I thought. Now that was a challenge. Although anything could be better than the scorching summer heat of New Delhi. So I agreed. I bought a book to study the Norwegian language, and I was interviewed by an officer in the Norwegian embassy in Delhi. He was a very nice person and gave me several hints on how things were in Norway. His name was Knut Myhre. Please remember that name because we are going to run into him many years later. It took some time to arrange matters, but in November that year, I found myself in the city of Oslo, which is the capital of Norway. It turned out that Norway also did not have any instruction for geophysics at any university. They did have a government institute which did prospecting for ore, looking for iron ore and copper ore and so on. Well, I thought I would join that institute anyway and learn some geophysics. I arrived in Norway and I was immediately faced with three challenges. I had to learn to speak Norwegian. The fellow students at the student hostel where I lived all insisted that I learn to speak Norwegian. The second challenge was I had to learn how to ski. Ski is those flat wooden things that you stand on to go around in the snow. Everybody in Norway skied, so I had to learn to do that too. By the way, learning to ski was useful. Many years later, I came to Norway for a skiing holiday with my wife and children. It was very nice that I had learned to ski earlier. The third challenge was more immediate. I had to go to my place of work in a bus and then walk 1 mile. It was November in Norway, and Norway is so far north that you have only 2 hours of daylight. So when you went to work, it was dark, and when you came home, it was dark. That was okay, except that I found that often the road that I was supposed to walk on was covered with a sheet of ice, and with my leather-soled shoes, it was a challenge. But I went to work anyway. 2 months later, the sun came out during the day and the ice melted away. I spent only 8 months in Norway, but as I look back, those 8 months were some of the most important 8 months in my life. I finally had to leave Norway and go to the United States, enroll in a university, and really study postgraduate geophysics. I left for the United States and enrolled in Columbia University in a postgraduate program in geophysics. I found an important difference in geophysics in Norway and at Columbia. While my work in Norway was all on land, my research at Columbia as a student, as a researcher, and as a professor was all at sea. In order to do research at sea, you need to be on a ship. And I worked on several kinds of ships. These included a fishing boat, a submarine, various research ships, a drill ship, and finally several industry ships. Each ship presented its own challenge. On the fishing boat, the work was quite simple. We had an instrument that had to be lowered to the sea bottom with a winch. The instrument was in a heavy case, but it just took a few minutes to bring the case down, then wait for 10 minutes while a reading was taken, and then bring the instrument up. We did that for a number of stations. While we were between stations, we did some fishing. We caught a lot of fish, cooked the fish right away, and it was indeed very delicious. So all in all, not a big challenge. Next, I would like to talk about my research aboard a submarine. The first question is, why do you have to go on a submarine to do your research? The answer is that some instruments do not work well when the ship is rolling and pitching and the waves with the waves, and you have to find a steady platform. A submarine can dive down a few hundred feet. It's calm down there, and you can use your instruments and make your measurements. The submarine that I was going to go on was not a fancy new nuclear submarine, but an old, leaky World War II British submarine. I joined the submarine in Freetown, which is port of the country called Sierra Leone in West Africa. And I was supposed to travel with the submarine for 4 months with some brief port stops at Cape Town and Durban in South Africa, Mogadishu in Somalia, and finally leave the submarine in Karachi. After we were out at sea, the way my equipment was supposed to work was I would ask the captain of the submarine that I would like to make a station at a certain spot. The submarine, if the captain agreed, would stop there and dive down to some pre-arranged depths. And I would take readings, which would take about 20 minutes. I asked the captain how deep could the submarine go, and he said 500 feet. I said, okay. So when we came to the stop to make a station, I said to the captain, let's go down to 500 feet, because I knew the deeper we go, the calmer it would be. So we started with the experiment, and after about 10 minutes, a sailor came down to me and said, hey, we have to go up. The blooming submarine is leaking. I ignored him and went on with my work. Then the first officer came along and he says, old boy, we have to go up. I said, well, after I finish my reading, it takes a few more minutes. And then the captain shows up and said, oh no, I give you 1 minute to secure the equipment and we're going up. And the deck of the submarine was awash under 6 inches of water. After that, I said to the captain, I won't go down to 500 feet, 300 feet is good enough. We stopped at the port of Cape Town and then at the port of Durban, also in South Africa. Some of you might know that Mahatma Gandhi started his protest movement in Durban, and there was still a big Indian community there. Learning that an Indian scientist is on board the submarine, they invited me to come and have tea and samosas with them, which was very nice, especially after the not so tasty British food for 3 months. The next stop was in Mogadishu in Somalia, and I think they were having a revolution there or something, and we did not spend much time there. I was taking reading all the way at stations, dropping down to 300 feet, and finally we stopped in Karachi, where I took the equipment off. I thought I would go to see my parents in India before I went back to the United States. So I got ready to buy a ticket to India, and I was told that you need an exit visa to leave the country. You get an entrance visa when you enter the country and an exit visa when you leave the country. I said, I don't have an entrance visa because I came here on a submarine. And now how do I get an exit visa? They said, you seem to be a spy for India and you have to go and talk to our big officer. So I had to go and visit the office of the big officer, and he asked me a few questions, and then he said, do you know anything about Pakistan? I said, oh, I've spent 1 year in a high school in Lahore, and I have an uncle who ran a newspaper there. And what's his name? I was asked, and I said, oh, his name is Virendra. Oh, I know. That is a very good family. You cannot be a spy being in such a good family. Now, that's the way things go in India and Pakistan. He called a servant and said, bring some tea for the Sahib. So I thought I got away very easily. But most of my research work was not carried on fishing boats or submarines, but on research vessels, mainly on a research vessel belonging to Columbia University. This research vessel stayed out at sea for as long as 25 or 26 days, and then there would be 3 or 4 days in port. Working on a research ship presents a number of challenges. One challenge is simply the month of isolation from the rest of the world at a time that there was no internet for communication and no GPS for positioning. You use the old-fashioned wireless for communication and located your position by using a telescope-like instrument called the sextant to look at the stars. By finding the angle to the star, you could locate your position, except when the sky was overcast and you could not see the stars. You could be lost for several days. That was quite a challenge. Another challenge is that when the sea is rough, the ship can roll and pitch quite a bit, and it's not very pleasant to be on board. A lot of people get seasick. Luckily, I didn't get very seasick. But if you ran into some very rough seas or even a hurricane, that could be quite unpleasant. One of the most dangerous experiments we had to do at sea involved working with an explosive called dynamite, which works like a bomb, but it does not explode by itself. You have to attach a fuse wire to it and light the fuse at one end. This is called making a charge. When the flame reaches the dynamite, which takes about 20 seconds, it explodes. So you make the charge in the lab, walk over to the deck, and throw the charge into the sea, and then it goes off. You have to do all this within 20 seconds. Otherwise, the dynamite will explode on the ship itself and sink it, which is not very pleasant, of course. So you have to be very, very careful. Now, this experiment was done on a routine basis every 3 minutes, and we did this day and night without stopping from almost the time the ship left the port and the ship arrived at the next port 25 days later. This was the biggest challenge on our ship. Another challenge was very interesting. We were up north in the Greenland Sea, only about 800 miles from the North Pole. It was very, very cold. We were surrounded by icebergs, and we really had to make our way through these icebergs. It was quite interesting to be so far north. On the other hand, it was very cold and dangerous to be surrounded by icebergs. An interesting thing happened. We got an invitation from the governor of a small island way up north. This island called Svalbard is the most northern habitable place in the world. As I remember, it was the month of August, but everywhere there was snow and ice and cold, of course. The governor invited the whole ship's crew and the scientists to a big feast. And that's one of the rewards of taking on the challenge of being so far north. Finally, let me say something about being on a drill ship. The drilling rig is lowered down to the bottom of the ocean, and it brings back samples of mud and rock. This is a big ship, and it doesn't roll and pitch. So life is quite comfortable, and the food that they give you is also very nice. So you would ask, what kind of challenge did you have on this sort of a fancy ship? Well, it turns out that my co-chief scientist, they generally have two scientists on the ship, was a Russian scientist. He was a good friend. And the two of us had to jointly decide where to drill. But he had to report to the Russian Academy of Sciences, and he had to follow the party line. I did not have any great party line to follow. I just wanted to do research. And so we had a number of arguments for every drill site, but we remained good friends. So there are some of the challenges in my career, and I don't expect you to have these particular challenges, but as Dr. Baker also said, you need to persevere. But whatever profession you choose, scientist or lawyer or doctor or software expert, you will always have some challenges, often with some rewards that come from facing these challenges. At the beginning of this talk, I mentioned the name Knut Møre, the Norwegian embassy officer I met in Delhi in 1953. I met him in 1981 when I was in Oslo, Norway, to get an honorary doctorate award from Oslo University, presented to me by the King of Norway. Mr. Møre was at that time the Norwegian ambassador to Denmark. He remembered me after 28 years and invited me to lunch in Oslo to celebrate the occasion. So that was quite pleasant. I think I'll stop here. I've said enough about what I've done at sea and what are the kind of challenges I had to face and how I try to face them. Thank you all very much. I'll take some questions.
It's such a wonderful journey you had. Like, I have known you for so long, but it's the first time I'm hearing this story about you. It's like all the listeners, it's like one fun part about being in the core sector. Like you get to be in the field and do real science. So like our questions, like most of the questions from you, Dr. Talwani, will be like related to like technology, like modern technology versus like the core sector. So one of the first question that I want to ask you, how easy it is to pursue a passion in science and research when financially it is becoming less and less lucrative day by day?
Well, I think there are differences in India and in the United States. I think in the United States, you have the luxury that in almost any profession, if you do well, you can earn well. You choose to do science because it's interesting and important and not to earn a lot of money. I don't know if that answers your question.
Yeah, like especially like for us, like a student who is like 25 years old, or if he has just graduated from a university with a bachelor's degree, if he has an option to go do some research where he's not get like versus the option to go into the tech sector and earn a lot of money. So how should one like decide like so even if like one has passion for science and research, it's most of the time it's a very difficult decision for a student who is not very financially secure and he has the pressure to earn money and livelihood, but he wants to do like research and follow his passion, but most of them kind of they have to sacrifice the passion over a demand for a better career and security in life.
That's a very good question, and often there's students that rise in our department have this question. I like research. I like to go, and but I have to teach at a university or something of that sort, and I don't make a whole lot of money. But I'm in Houston, and there are a lot of oil companies that offer big jobs. They are not research and they're not intellectually often as challenging, but I get more money. And I have a wife and children, and my wife thinks it's not a bad idea to make a little money now that you've spent so much time. So it's a personal decision, and I think I encourage people that if you are inclined towards research, and you're not doing research just to make money, stay with that. If, on the other hand, research is just another way to have a profession, and there's nothing wrong with that, then you go ahead and find and work for industry or open a business for yourself. So I think it's a personal challenge, and it depends on your inclination. And also, if you consult your wife, that's very important.
Yep. 'Thank you. And one more question is that, like, what is the difference between science and research? Like, what is the difference between science and research? And how should one decide, like, like, so even if like one has passion for science and research, it's most of the time it's a very difficult decision for a student who is not very financially secure and he has the pressure to earn money and livelihood, but he wants to do like research and follow his passion, but most of them kind of they have to sacrifice the passion over a demand for a better career and security in life. like what's the like so in the modern world we have a kind of explosion of technology, especially related to IT. So at some point we have to find a balance between software driven sector versus the core sector. So if suppose a student qualifies IIT JEE, then he has the option to study computer science, and he gets the option to go in a core sector. And most of the time, given not so bright scenario for the core sector, most of them they prefer to go and study computer science and feel that will get into the tech sector. So they need some kind of motivation and vision into the future of core sector, like how good is it going to be in future, like if they decide to be a geophysicist or a mining engineer, or a civil engineer, security wise and financially, is it like a good choice for them?
Well, I think if I understand your question, uh, doing IT work and software is very popular in India, and I think is quite lucrative. On the other hand, being a scientist and being an engineer, uh, I think intellectually challenging and rewarding. And India has a lot of problems that can have to be solved with science. For example, water. We have a shortage of water in many parts of India. And on the other hand, a lot of water goes and flows out in the two major rivers and goes out to sea. So there has to be some way to save that water or find ways where you can have better ways of exploring for groundwater. And so finding enough water is a big challenge. Uh, India is used to be a big problem that it did not have much hydrocarbons, but the world is shifting now to renewables. And India has as good an opportunity as anybody else to become a leader in renewable work. And that could be also in the future quite challenging and quite lucrative. So again, it's the choices that you have to make.
And Dr. Talwani, so over the last 50, 60 years, I think you have seen how our this industry has evolved. So what difference you see in the world that was 50 years ago, when the world was driven by different needs and interests, versus now, where we are more technology driven and it is evolving so fast. So how a modern young professional should cope up with this just rapid change? Can you get some insight from the past?
The short answer is you have to go with the change, otherwise you get left behind. If you want to stay in technology, you have to, and as you're right, it changes very fast, but you cannot go back to your old-fashioned way of doing things. You have no choice. And I think, especially in India, the way to progress is through technology, and the eradication of poverty is going to be through technology. So that's very important. And you have good IITs, good schools, and so on. And there's no reason that you can pursue the latest things in technology and stay with them.
One of the questions is from our audience. He asked, in India, even after PhD, students opt for career in banks because bureaucracy and other walks, because a research career is at stake, as based on research projects, there are no jobs. So basically they have to go with the job that can earn their money. So there's a problem that we don't have much job in research related field, or after PhD, students are not able to secure job for themselves. So is there any possible solution for near future?
Well, in India, most of the research is done by government institutions. And much more research needs to be done at university, even in smaller university. Rice is an excellent example. It's a very small university, but it is the faculty here in all departments are the leaders in research. And so the trick is, how do you fund the university? There's some state universities that can get money from the states, and there's some private universities that have endowments. In India, I think the way to progress is to not just have the government do anything, or the government can fund in various provinces. They can fund and encourage some research. I know Banaras University does some research, but by and large, the fanciest research is left to government institutions. I think if there was some way of providing more money to the provincial universities and so on, and bring research within the province of, within the possibility of many more people, I think that would be very useful.
Okay, I think we had enough questions. Like on the final note, like I would like to ask you to have a few words of advice to school students, especially from grade 6 to 12, how they should study to get like selected in a good college, and how they can get a good score, and what qualities it takes to excel in academia.
That's a hard one. I have 8 grandchildren, and my youngest 2, one of them just likes to study, and she's very, very smart, and so on. And her brother is also quite smart, but he doesn't like to study as much. And but he's very good at other things. He's very good at public speaking and so on. So I think something that Dr. Baker also suggested, that you have to exploit your own tendencies and your own talents. And I think that's a way to encourage people, not to have them all follow the same line, but expand out and try various things as it suits your particular talents.
Thank you. I think that was very wonderful talking to you, and thank you for such like nice words and words of advice to students.